So I moved to Detroit about 2 years ago to really try to understand manufacturing more, where it's at now and where it might be going. There's no question that we do some really impressive things, and also things are changing really fast. And one of the things that's changing rapidly is AI. I wanted to talk about how it's changing manufacturing, but not just the headlines, actually like what's happening on the ground, and get deeper into some of these examples. I'm optimistic about their potential, but they're not all winners, and there's definitely a lot of challenges. So I want to talk on how some of these everyday tools like ChatGPT and Gemini and Nano Banana, how these can be utilized, but how other folks are utilizing AI in very interesting and different ways, because there's so much potential with that. And if you can use tools to give you a competitive edge, it can be really valuable. I think when a lot of people think about AI, they think about robotics and humanoid robots. There's no doubt that AI is changing robotics in a very dramatic way. This is an area I see tremendous potential with, and there are really practical ways I've seen and even tested myself in manufacturing that can allow folks to be a lot more efficient and effective and be creative with getting the job done in new and different ways and really discovering new opportunities. But before we get into all these different things, I think it's good to set some baseline definitions of some of the terms that are commonplace. So you have AI, artificial intelligence. You can think of this as the overarching discipline of computer science. But inside of that, you have other things like machine learning. Historically, with coding, you effectively are writing a rule book, and the computer is just following that rule book. But with machine learning, it's kind of like hiring an apprentice. You show some examples, and the computer effectively learns the rules itself. If machine learning is the brain, deep learning is like the eyes and ears. This is what gives machines senses. It allows a machine to see a scratch on a part or hear a bearing that's grinding. You have generative AI, which is seen commonly in design. Next, you have LLMs, or large language models, ChatGPT, Gemini. Think of this as the front office. Machines speak code, humans speak messy English. An LLM is effectively the translator. And finally, physical AI. This is really not talked about too much, and I don't even know if this is an official term, but ultimately this is something I anticipate seeing more and more of. When a digital brain gets a physical body, this is the difference between a robot that blindly follows a coordinate and a robot that feels resistance and adjusts its grip. Now, all of these technologies are used in some ways in manufacturing today. Obviously, not everybody's using all these technologies, but there's opportunities to implement them in some ways. And I realized that not many people are explaining what's really going on, and a lot of videos are from a couple years ago, and so much has changed in this short period of time. Just last week, the US government announced this Genesis mission, which plans to leverage national labs and bring AI together, and they see a lot of opportunities with deploying that into manufacturing. The LLMs are moving rapidly. That's what a lot of people hear about. Even that, we can use these tools, LLMs, in very practical ways. I've used it myself, even just to operate in this shop space. You have to have something called a job safety analysis. And generating those can be really tedious. One of the things that I found is that you're able to take documentation from a machine, bring it into an LLM and say, hey, I want to produce a job safety analysis. The great thing is that there's loads of different references of what a good job safety analysis is, and it's pretty easy to put that together. We've seen this safety thing go all sorts of different ways as well, but in this example, as in many others, you could have issues where there could be blind spots. You could have these hallucinations, and if you get data that's not correct, it could be a hazard. So you really need to be careful about this stuff. I think there's still a lot of opportunities to use these tools, and they're getting better and better really every day. Now, I really want to focus this video on practical examples of how we're using AI on the shop floor, actually in manufacturing, but I'd be remiss not to specifically talk about the design and engineering phase, which has been one of the areas that there's been loads of development on, and really has come quite a long way in our ability to take a basic sketch and make that into something that can actually be built. Even just recently, it's becoming more and more accessible where you can start to use publicly available AI tools like Nano Banana from Google, where you can take a sketch and actually generate drawings. And it might not be perfect, but it gets closer to the point where you can hand it off to somebody that, is a professional and they can develop that. Now, I'm not foolish to think that this is perfect or you can just do this and it's just going to work. It's definitely a developing area and there's a lot more work to do, but it's coming a long way and some areas are moving faster than others. But I would encourage you, if you've had trouble in the past, to keep an eye on it. Experiment every so often because you might be surprised on what's actually possible. We're getting closer to the point where this napkin sketch can actually get us so much further than it once did. But say you're able to make this part, great. How do you know it's actually good? Now, this is another area that AI can help. Usually automated inspection is a nightmare. And if anything is off, even lighting, it could fail. But there's a lot of developments in this area. There's something called the large vision model. One company, Landing AI, has been working on this. For example, you want to find if there's a scratch in this part that you just made. Instead of programming the rules, you just draw a box around the scratch on 5 or 10 photos, and the AI learns what a scratch looks like, just like a human would. There's even AI systems that can generate these defects to use in machine learning to train the model. You're using generative AI to create defects. Say the color's wrong or has a scratch or the size is wrong. You can use those as examples to train a machine learning model to help it understand what bad looks like. Another example of deep learning is when you have machines and you want to make sure that they're running right. You can actually add a sensor to that machine as simple as a microphone. And these tools can give you a lot of data, and you could have an AI system listening for anomalies. If you could know what's going on with that machine and you can actually prevent it from going down, that could be really valuable. And one of the more expensive things in manufacturing is tooling. It takes a lot of time to develop and it costs a lot of money. For anybody that is familiar with injection molding, it's a bit of a dark art. Designing cooling chambers so the plastic doesn't warp is very challenging. Companies like Atomic Industries are automating that process. They use AI to simulate the physics of that flow. The AI runs thousands of simulations to grow cooling channels to wrap around a part like veins. It's using compute to effectively solve physics. But one of the biggest bottlenecks in the factory is the robot. Right now, industrial robots are dumb. They follow a script. If a part is a few millimeters off, it misses. If you bump it, it stops. It has no intuition. I've been following the work out of an MIT lab on liquid neural networks. They proved that you can run a liquid brain on a simple chip. They tested this on self-driving vehicles, but in our application, let's use a robotic arm. Because the network is liquid, meaning it adapts to the environment, you don't have to program in every single waypoint. It learns and adapts. You can use things like this to help with grip. If the part is starting to slip, the robot can automatically adjust. If a human steps too closely, it slows down automatically. It basically turns a dumb robot into a teammate that understands physics. But there's all sorts of other robots that exist in a factory setting, and that's something that's been around for a long time. But getting those robots to work together, to work with humans, work with different systems, that's a big challenge. There's another group that I'm familiar with called Fleet Glue. They're basically building an operating system for these robots. The founder, Danny, his family had a factory and they started to implement these different solutions and recognize that they don't talk to each other. They don't work well together. But he basically wrote a system that helps those devices work together. And when you combine that liquid brain with flexible arms, you can do things like what these guys at Makina Labs are doing. Basically what they do is incremental sheet forming. You have two robots, one on either side, pushing the metal in different directions and just stretching it and forming it. And it's quite cool what they're able to do. And I'm excited to see more and more development in this area. When you want to produce automotive parts, say like the trunk of a pickup truck, you have to produce a really expensive tool for that. It's a massive piece of metal, which basically allows you to stamp that part. But they're able to do this kind of one-off. And this is actually the dream in many ways, this custom at scale. And I think that we're starting to see opportunities, still kind of early days, still kind of expensive, but you can actually customize things more and more. And speaking more about this flexible manufacturing and assembly, Hyundai has this facility in Singapore where they have these flexible cells. Most manufacturing for automobiles is relatively fixed. You have a fixed line, you're producing one vehicle, maybe there's some variation. But with this strategy and the way that they structured it, they're using AI to adapt and change and adjust. And they're able to produce an SUV and a compact car all in the same cells. And they have these individual cells. One might be a cell for installing seats, one might be for painting. They're very flexible. Now, it takes a lot more investment up front, but they're able to produce a lot more vehicles in a relatively small area with a pretty small team. You really need to leverage AI for a lot of aspects of this, like when does a product needs to go to this cell, or maybe it divert to another cell because it's not ready. You're adapting these robots to different work instructions. Many companies are leveraging AI to do that. There's one company called Dirac, which they basically are able to take a CAD file and break it down into the work instructions, how to assemble it, torque values, what to look out for. And it links the work instructions directly to your CAD. So if an engineer changes a bolt size, it automatically updates the work instructions. And there's also some investment going into this space as well. Even the government is making some serious investments. They're effectively betting the house that physical AI is the key to bringing manufacturing back home. But here's the friction point I kept on hitting. We have these amazing tools and they're getting smarter and smarter, and we're really improving the efficiency with how we actually build things. But then we have the challenge of actually connecting to the capacity and capability of these amazing companies and tools. That's really what I'm working on with Bloom. We built AI native infrastructure specifically for this purpose. And at its core, it's a conversational engine. But it's not just a chatbot, it's a workspace. You can drop in your drawings and documentation, and we can collectively edit the RFP right in the chat. The AI gives you guidance on your files and provides feedback on the scope, and it helps to make sure that it's actually ready to be built. And once the package is ready, it doesn't just search for a provider. Actually, we're building an autonomous agent that can find the perfect match based on real-time capabilities. Now, this is a really big undertaking and it's not happening overnight, but we're making a lot of progress and it's pretty exciting because really this coordination layer is not to be underestimated. There's a reason why companies like Alibaba are such massive enterprises. The tools we talked about today, liquid networks for robots, generative design for the parts, and what I'm building with Bloom for the supply chain side of things, they're all part of the same shift. The barrier to entry is gone. You don't need $1 million to build hardware anymore. You just need a good idea and the right tools. There's loads of different examples, and I anticipate covering more of them in the future. Love to hear what you guys are seeing. We're in a weird and exciting transition. I'm very optimistic about what we'll see in the future. I wonder what you guys are seeing. And I look forward to covering more of these topics in the future. So, well, until next time, take care.